easier than what you actually think. When I look at the model about throwing a shot put, and it says that the model is after y equals negative something something plus x plus 5.5. Think about it in terms of what that means on a graph. What does that 5.5 represent? Y-intercept. Now, yesterday we talked about the cannon. The cannon shot from the ground. There was no zero. There was nothing tacked on there. The cannon shot from the ground and went kaboom, and it blew up somewhere. Good old Jackie Joyner Kersey is throwing a shot put from here. She's throwing it from 5.5 feet up off the ground. So you have to think about, when you're looking at the graph of this, it's going up and out. It's starting at the y-axis. It's starting here, and it's going out to here. Think about what we did yesterday. Will the axis of symmetry allow me to figure out that halfway point to double to get to my, how far did it go? No, and the reason is because the parabola goes behind itself. Because it's starting at 5.5, it's got to fall back to here. Okay? I can't use that axis of symmetry to double to get out there. But what I can do is just put it in my calculator and just figure out the zero on that end. That's it. That's all that is. That's all you have to do on this problem. Here we have, let me clear this up. Y equals, what was it, negative 0.00,
No, not 2 0.
just 1 0?
Yeah. 2 4 1.
X squared plus,
Plus x.
just plus x,
Yeah.
and then 5.5.
Yeah.
So if I look at just, oh yeah. So if I look at my window's all messed. So I'm just going to say my window at negative 10. I'm going to put my maximum. Realistically, how far do you think someone's throwing a shot put? 50 feet? 100 feet? Think someone's throwing a shot put 100 feet? Probably not. So let's just make our maximum. I tried to open the door, it didn't work. Let's put our maximum at 100. We should be able to see it. Okay? Put our maximum, or x maximum at 100. How high up do you think she's throwing the shot put? Maybe 20 feet, maybe 25 feet, I don't know. I haven't thrown a shot put since I was in 8th grade. Yes, ma'am? We'll look at your window. We're adjusting our window right now to play with the window. What I've done here is adjusted my window.
What is this? I don't know what this is.
Your window's all messed up. Hit quit and hit window again.
Wait, what is on?
I put my maximum at 50. Obviously, it doesn't need to be. I have my x minimum at what I think it was, negative 10.
And then the x max.
I put my x maximum at 100.
And then
My y minimum at negative 10. My y maximum at 50. Right now, I can see basically this whole graph.
it's back. I don't know what I'm doing wrong, but I tried so hard to see how to look at that.
So like check one and then like a bunch of random numbers.
Nope, it just says error, something, something.
Mine's been doing the same thing. Like just weird.
Oh, your stats on, that's why.
Yep, that's it, right there.
All right, your stat plot was on. Turn the stat plot off. Okay, what I want you, if you're getting really weird error messages and you have no flipping clue why, there's a button sequence you press. Second plus 712. Second plus 722. Oops. And that resets the defaults. You'll have to retype in your equation, but that'll help. So if you need to reset the calculator because you have no idea what's going on. What happened?
I just broke my physics.
Oh,
It
because
just
it cleared it.
resets.
Yeah, I didn't know you had stuff in there. That'll reset everything. If you don't know what's wrong with your calculator, you're not sure where everything went, that resets your defaults, that restores things out. What we're doing here is we're trying to figure out this distance is some value of x right here. We need to find that x value. That x value is a 0 of the curve. So what we're going to do is calculate second trace. We're going to calculate the 0, option number 2. And remember, when we're calculating zeros, it depends on what side of the graph we're looking for. Right now I'm looking at that right side of the curve. So if I'm looking at the right side of the curve where it's crossing over, my left boundary is going to be above the axis. My right boundary is going to be below it. So I need to put my cursor on some value that y is positive, and then pick a value where y is negative. Does that make sense?
Guess again.
No?
I don't get that.
Okay.
You gotta do the guess.
They all look the same.
Here's a number. Here's 1. Here's 2.
Yeah.
This curve is crossing somewhere between 1 and 2.
Yeah.
These values of y are positive up here.
Okay.
So I pick a left boundary of the curve above the graph.
So is left boundary always positive?
Depends on what side of the curve you're on. I'm looking for this value here, so as I'm reading to get to that, the boundary to the left of it is positive. The boundary to the right of it is negative.
Oh, you mean right of the point on the, like, so the point we're finding on like the
Mhm.
x-axis, so if it's to the left of it,
Yeah.
that, oh, that makes sense.
That's really all it is. Because if you're on this side, you want to be to the left of where it crosses, to the right of where it crosses. That's all left bound, right bound means.
Well, I didn't get that at all.
Okay,
How did I do that?
Again, let me start over. Second, calculate. 2 is a 0. I want to be a left boundary where it crossed. The left boundary where it's crossing is when y is still positive. Okay, so I need to put my cursor so that y is positive. You guys-
Does it matter how like far you are up? Or you
The
know,
closer the better. Yeah, the closer the better. You'll get a little bit better of a
Okay.
approximate. We're talking thousands.
Okay.
Okay.
That's what I said.
Guys? One second. Yes, sir.
Can I get the better, please?
Give me a second.
Wait, do I get?
Because it's searching for this value. The calculator will search for what that is at 0. You're telling it what to look for. You're telling the calculator by finding this, by hitting the button that says calculate 0. The calculator is looking at. I've had it, guys. I'm sick and tired of listening to the laughter over there. Okay? It's enough. There's a lot of people in here that are having questions. If you don't, great. But we shouldn't have to deal with listening to you guys talk. Okay? What the calculator is doing is it has in there a program that is looking for what value of x is making y equal to 0. And you're setting parameters for it to search. The closer the parameters are, the better the search. Just like using Google. If I Google doctor, it's it's going to give me a lot. If I Google neurological pathologist childhood doctor, I'll get like smaller amount. That's all it is. You're narrowing the gap of variance. That's all this calculator is doing for you. And you're just pressing a button. If you want to use the quadratic formula and find it the other way, that's fine. Do it. This is faster. Okay? That's all we're doing. All right? But yeah.
When you press up the gas,
Enter. So I have my left boundary where y is, yes sir.
Okay, couldn't you just like set y to 0 and then solve for x?
Sure.
yeah, how do you set y to 0? I'm trying to do that too.
Go ahead and figure out what times what is negative. You can factor it. You can use quadratic formula. You can use completing the square. You can do any of those. This is just faster. So if you want to solve it the other way, go for it.
I'm not saying that. I love technology.
Yeah, but no, I'm saying you can do that. There's no reason you can't.
Yeah, but
Sometimes it is faster when you have to use quadratic formula. And I'm going to show you an example of that here real fast. So all we have to do, we got a positive value y, hit enter. The right boundary, I want a negative value of y, hit enter. And then I hit enter one more time. That whole guess idea, I don't know what it means. It just means, hello. Is it me you're looking for?
Yes, it is.
Oh, gee. Attention, Mr. Murphy. The people at Mathnasium want to get me stuff. Now, in this case here, this 1 e to the negative 12 means 0.000000000001, I think. Or maybe 1 less 0. It basically means 0. Okay? Your value of x is 46.41 feet. She threw the shot put 46.41. I think it's in feet, right?
Yeah.
Feet. That's all it's doing for you. The buttons do it. Okay? You want to use quadratic formula? It works. What do you guys got?
okay, so is the 46.41, is that from the
It's
wider step to the x
It's
step?
what is this value of x from here to here? Because this is where it started. It started at 0.
So it doesn't take into account.
Nope. That's a different 0.
Okay, I'm still lost.
That would be, if you took that into consideration, then you'd have to worry about axis of symmetry and a shift. Sorry. All right, if you're so that loss, you just use the quadratic formula. You're fine. Guys, I gotta go to another question here. We got a whole bunch more to go through. What else you got on this one? Yeah, I usually go 2 decimal places. Always go 2 decimals. So it'll be 100. Okay? Maria?
Oh, okay, I was just wondering, like, on my calculator, it says, like, 1 e, negative 12.
Yeah.
I mean, 3 e, negative 12, because
It's like, what happened there is that your window might have been a little bit different than mine. You might have picked 2 very similar values. It's still 0. It's still 0, because that's 0.000003 as opposed to my 0.000001. Your x value is still 46.41, right?
yeah.
You're going to have that little variance within thousands of points. Okay? Ladies, last one of this.
Just the 1 e, negative 12.
I've said that 3 times. It's okay.
My question is just, how am I supposed to know what to do for what problem?
You can use any method for any problem. It's an idea of what's going to be the fastest for you to figure out. They're quadratics. You visualize what it's doing.
So you just make each of them a quadratic number?
Well, they are what? No, they already are.
So you just put all of them?
You can.
What's that?
Well, what about that other stuff that you discussed yesterday?
Same deal. I'll show you that in a second. Let's go to, yes ma'am.
How would you find the height?
It's the maximum. Back on this one, the height, the maximum height, you would use calculate maximum. The calculate height for that one, if you want to figure out the maximum height, we hit second, calculate. It was down like a frown, therefore the high point is a maximum. I want to move my cursor to the left of where I believe the maximum is occurring. I'll hit enter. Move it to the right of where I think the maximum is occurring. Hit enter. Hit enter one more time. And it's telling me I'm having a maximum value. Oops. It's saying that we have a maximum value occurring at 20.75 for x, but it has a height value of 15.87. Which of those is how high up it was? The 15, yeah. Because that's your vertical height there. Why is your vertical height? It occurred when it was 20 feet out. It was almost 16 feet up. So you'll see that quite often. It'll ask you what was the maximum height of the object. And that's just finding the maximum by pressing a button in the calculator. Left of it to the right of it. You still got to do those boundaries. It'll tells you what to the hash. It says left bound, right bound again. So be to the left of the maximum, right of the maximum. You can see it moving up and down. You can watch the values go up and then come back down. So you just want to be on both sides of it. It's just a matter of playing around with the calculator. With this same idea, go back to the electronics one before we get into the initial velocity. Initial velocity is ridiculously easy to use, but I want to make sure we got our cost and sales one okay. When we did this one yesterday, something similar to that, we did a cost and sales figure for when sales, or excuse me, the cost increases, sale decreases, or cost decreases, sales increases, something along those lines. These are setting you up to be what in the form of intercept form. If you remember from yesterday, when we did the shoe sales one, we had what was it, price and units, I think. Sales, yeah, sales, we'll use sales. So you wind up with two terms, okay? If you look at the first one, in the electronics, we're talking about selling cameras. Well, if you're selling cameras, your current price is $680, and you sell about 70 of them. So right off the bat, you have a price of $680, and you're selling 70. The variance occurs when you start to bring in the, for every $20 decrease in price, you sell 5 more cameras. So what they're saying here is that every time I drop the price by 20 bucks, my sales will increase by 5. So drop the price by 20, I get 5 more. Drop it by 40, I get 10 more. And so on. That's where the value of X comes into play. That value of X is the multiplier to both of those. If I decrease the price by 20, I increase my sales by 5. Okay? Now, again, this scenario with this.
Why would you use the same variable for minus 20x and plus 5x? Because aren't those different?
For every decrease in $20, one decrease creates one $5 increase in sales. 2 decreases creates 2 increases of 5 in sales. 3 decreases creates 3 of those. That correlation between the variable just X has to work for both of them. Okay? Because if you drop the price by 4 times 20, your sales will increase 4 times 5. Does that make sense?
Yeah.
That's the relationship there. That's how these quadratic setups work. Okay? Now, I will say one thing about these cost side. This is written right off the bat in that intercept form. When you have intercept form, you can find your zeros really fast. Set them equal to 0 and solve. Yes, no, maybe so. Could I use my calculator, put that in my calculator and do all that whole calculate zeros and all that stuff? Absolutely. This case, it's quicker to do this. If I set this equal to 0 and solve for x, I would add 20x and divide by 20. So what's 68 divided by 2? 34. So I have a 0 at 34. What's 70 divided by negative 5? It has zeros at negative 14 and positive 34. I know it's negative. I know it's down like a frown because minus 20x for decrease plus 5x in sales. So my x squared term winds up being downward. What occurs at the halfway point? At maximum sales, the axis of symmetry. What's negative 14 plus 34? So I know that at 20, comma, something is going to be my maximum value. It's quicker when you're in the intercept form to plot it out that way as opposed to using the calculator. Don't get me wrong, if you want to use your calculator, that's great, it's fine. All I'm saying is that sometimes it's easier to do a different method. And that's why I wanted to make sure I show you guys that the calculator is great, but it's still only as smart as the person pressing the buttons. Okay? Yes, sir? Oh, I forgot to divide it by 2, didn't I? Yeah, it's supposed to be 10. Sorry, I forgot to divide it by 2. Yeah, JC? Yeah, I just realized like I got the halfway and then I'm like, wait, it's the midpoint. Duh. Maybe I should use the calculator. Wait, what? It's midpoint. Axis of symmetry is the midpoint. I know I add them together. What's 34 plus negative 14? 20. What's half of that? 10. 10 is 24 away from 34. 10 is 24 away from negative 14. Did you?
No, that's 14.
Oh, never mind. Ignore me.
So 10 is my value. The maximum revenue then multiply them through, and you'll generate your revenues out. So, okay. That's really all it is. Yes, sir.
I'm still kind of confused on how you got negative 14 and 34.
What are your zeros?
3 and negative 4.
Okay.
Yeah.
This one has to do this. Okay, it's the same idea.
Okay, all right.
See where I'm going with that? It's just for bigger value setting equal to 0.
So you have to
set the term equal to 0 gets you a 0.
But then wouldn't the zeros be 687 then in that equation?
No, because it was 680 minus 20x.
Okay, yeah. All right, okay, yeah.
See where
Okay,
I'm going now?
thank you very much.
Same, it's the same process, same way to solve it, just bigger numbers.
Anybody get the Y?
Okay. So using intercepts with cost ones, they're easier. It's easier than using the calculator. At least I think, if I know how to take half of 20.
You're fine.
Did we need a Y value for that?
Yeah, you just get it all in the calculator. It goes to the revenue there. Let's talk about initial velocity. And third hour was asking about this, because we didn't get a chance to talk about this yesterday. When you're modeling initial velocity or objects being dropped, you kind of have to have the model to help you set it up. The difference here is the following. What am I doing? Did I give it any push or anything like that? No. I just let it go.
No.
Let it go. Sorry. I just dropped it. The moment I throw it, I gave it velocity outward. Okay? So the difference between the two is that a drop and throw. So when you're looking at that, if an object is just dropped, or if an object is launched, the cannon had some velocity to go outward. There's the differences here. So you wind up with these, let me snap this into the other one. You wind up with how the problem sets it up. And they're really very, very easy to work with. And I told third hour that it's not something that you have to memorize. If there is a problem that we will use this, I'm going to use the volleyball one for this on the next page. Then you'll see how really, really easy it is to work with. So think about good old JC. JC, come here.
Oh, God. Wait, up there?
Yes, because I'm going to set you, you're going to spike.
Isn't that a ball?
No, it's a tape ball.
What about the projectile?
I would move away from the light, that thing. You're just ready? Because don't jump and hit the projector.
I'm jumping?
Well, yeah, you're going to spike it. I'm going to set you. Ready?
Can't even jump.
Awesome! She hit. That didn't hurt. I just realized that.
Not really.
Okay.
Oh my.
Wait, you're the setter. You're the spiker.
Yeah.
Go set her. Set her back over there. Do it back there so you don't hurt anybody. Then we need to hit this. Watch! We have volleyball in our classroom. This is the greatest day ever. Try not to kill each
the
other.
flag.
Well, why don't you move away? Here, why don't you go stand over here?
Chris.
Anon, watch your head. Tuck and cover.
Right there. Okay.
Hey! Look at this, real world math. All right. Thanks, guys. You have a volleyball game. The team spikes the ball over the net when the ball is 10 feet from the court. Can you dunk, Jackson?
No.
10 feet, that's dunking there. Now, that tells you a couple things. It also tells you that it has a downward initial velocity of negative 55 feet per second. Okay? So right off the bat, they're telling you that you have some initial velocity, which means you have to use the second model because it's being hit downward as opposed to being dropped. Okay? So your problems here will always start out with this negative 16 t squared. We're trying to solve for t in this case because we're looking to figure out how many seconds we have until we have to hit the ball back up in the air or it explodes. Yeah. It deals with gravity. It goes with that side. You have this initial velocity. Our initial velocity was negative 55 feet per second. So there's our V, what's called V sub O. V sub O, velocity original. Convenient.
Holy poop.
So you have negative 55 t, because the t comes along. H sub O, height original. What's the original height it was being hit from? There you go. This is your quadratic. Now, in this case, what would be the easiest, quickest way to solve the problem? The quadratic formula. I'm not going to lie. It's real quick to solve the quadratic formula.
Can you say that to us, please?
Yes. Let me take this and move this down here. X equals negative b plus or minus square root b squared minus 4ac all over 2. So anyway, the reason why I'm going to say use the quadratic formula here is think about what the parabola is going to give you. The parabola could give you a positive and a negative value, couldn't it? Can you have negative time?
No.
Are we going 88 miles an hour in a DeLorean? No. So all we're doing here is substituting in. And I'll show you what happens here. Opposite of b, so we have 55, plus or minus the square root. I know that our b value is negative, but I know how you guys work. You're going to screw this up. So just write down 55 squared minus 4 times negative 16 times 10. All over negative 32. All I did there was just multiplied the negative 16 by 2. Are we okay with that? Yeah. All right. when I go to my calculator to type this stuff in, I'm going to type in the discriminant first. What part's the discriminant again? Good, the junk underneath the radical. And in doing so, we get what? 55 squared minus 4 times negative 16 times 10.
Yeah.
We get 3665. Okay? 55 plus the square root of 3665 over negative 32. Or
Wait,
55 minus the square root of 3665 over negative 32. Which of those two values is going to give me a positive time?
The negative.
The negative one will. And the reason that is because the square root of 3665, well, if you think about it in just numerology, I think? Whatever. What's 6 squared? What's 60 squared? Bless you. 3,600. 3,600, add 2 zeros. So I know that 3665 square root's got to be around 60-ish. I'll therefore get a negative divided by a negative, which gives me positive.
Yay!
So in my calculator, make sure when you're using fractions, alpha, y equals, enter. That's how you create the fraction bar in these calculators. Alpha, y equals. When you have 2 parts to do with the numerator, please, 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 please do a fraction bar with the calculator. Don't just go, what was it, 55 minus root this divided by. It will only divide it by the radical, it won't divide the whole thing. So we had 55 minus square root 3665 over negative 32. And you have 0.17 seconds to react from Jasmine's killer slam. Exactly.
Yay!
Like I said, there are many, many, many different methods to solve these quadratics word problems. It's a matter of what you are most comfortable in using. If you wanted to graph that function, it's fine. It just takes a little bit more time to go through and find your window to set it up and look for your zeros. This might be a little bit difficult to find because if you look at the zero, it's really, really close to 0. So you'd have to make your window very, very, very with small values, like 0.5 for x maximum and minimums, okay? Things like that. Utilize your thought as you're going through the process of figuring out where you're looking for things, okay? What I want you guys to keep doing is try to finish out as much of this as you can tonight. I did make a copy of a bunch of review stuff from the rest of the things in the chapter. It has all the answers on it, so you can check your work. What we're going to do is go through as much of what's left with this packet, thank you, sir, what's left with this packet tomorrow, as well as any of the questions you guys wind up getting stumped on at all in here. This encompasses everything that I can possibly think of to put on the test.
Wait.
The only thing that's not on this review thing are some word problems. I kind of gave you all the ones that I can come up with.
Is it actually a test or is it a quiz?
That's a test. We'll call this a test.
So it's going to cover more than just chapter 5?
No, it's just all 5.
Oh.
It's just all 5.
Did you not get
No, I'm sure I did.
wait, and everything.
Oh, and I don't have email right now. They kicked me off the Google again, so you can't email me.
And everything imaginary.
What's up? Yeah, you like that one? Everything imaginary? I had a parent email me back, and so they're like, I'm not sure what you did there, but I think I kind of get it. So I emailed back, and I said, imaginary I. And then she's like, oh, that's just bad.
So is this homework over?
Yeah. Don't try to finish all of this tonight. Really, really don't. We're going to go over this over the next couple of days. I haven't quite decided yet whether or not I'm going to collect it on Friday because on the back page are all of the answers. So hopefully you'll check your work.
Great.
Okay? Yes, Maria. What do you got? I can't do that because my Gmail, I'm logged out of all Gmail. I can't even get into it. So I'm sorry. I can't.
Hey, if you need to.
Chimky, what do you got? Yeah. Pause this one out.
You're fine.
Yes, sir.
I wasn't here yesterday and
Right.
you gave me the wrong, like, you gave me this.
Oh, I'm sorry. I thought I grabbed I'll grab the other one from you. I'm sorry. I thought I
should
grabbed.
have said something because I was really, really confused.